Hello, everyone. I am Professor Yingzhe Huang, the leader of the Smart Aquaculture team of National Sun Yat-sen University. We are experts in computer and aquaculture technologies. I am proud to present our smart farming solution to you. Shrimp is a popular and highly valued aquaculture product worldwide. To produce such a large quantity of shrimps, intensive inland farming is necessary. However, shrimps live in muddy and turbid water. How do you know their growth, health, and feeding? The typical approach is like this: manually pulling the check tray to take a quick, possibly incomplete observation. Like blind man and elephant, it is subjective, labor-intensive, and non-systematic. Therefore, we propose a smarter way, a smart underwater surveillance system based on AI technologies, which consists of image enhancement, automatic shrimp and feed detection, smart edge devices. Together, they help you to systematically manage your shrimp ponds in an intelligent way. This is a model of a smart shrimp pond with network devices, such as feeders and motors. The critical device is the underwater camera, which allows us to directly observe the shrimp and feed situation. That is not possible in traditional farming. We then send this information through network to the cloud server, where we can conduct both automatic and manual analysis and make proper decisions to control the automatic devices. And then we can double check again the underwater situation to see if the decisions are effective or not. With this system, we accomplish a complete control circle, which is not possible in traditional farming. We have cooperated with our supplier to develop an IP camera that is saltwater proof, works in turbid water, and also works in days and nights. With such camera, we can develop AI-based smart functions, such as image enhancement, shrimp behavior analysis, and feeding status analysis. In the following slides, I will briefly explain these functions. First, we are able to enhance the underwater video in real time. The picture to the left is the original video taken in a dark and turbid water. The picture to the right is the enhanced video, where you can see the details of the shrimps become more clear. And a shrimp hidden in the upper left corner can be seen in the enhanced video, but not in the original video. This greatly enhanced the underwater image quality, so both human and computer can obtain more information. Therefore, we are able to directly observe shrimps underwater without taking them out of water. Based on our experiment, we are able to observe thousands of shrimps per camera per day, right where they are living. That is a few hundred times more than what can be observed by traditional methods. Therefore, this greatly enhanced the understanding of shrimps in the water. We can measure the moving speed of shrimps and perform the statistics analysis, which can be indication of shrimp health and feeding situations. Since we are able to see shrimps clearly, we can then measure their individual size with our AI technique. Therefore, we can analyze how shrimps grow day by day. In addition, since we can measure the size of each shrimp, we can count the shrimps of different sizes such as small, medium, and large size. This is very helpful for management. First, we can observe the average growth of each stage. Secondly, we can further analyze the size distribution as days go by to see how each group changes its population. So you know if each group grows up normally and when you will have enough population of a particular size for you to harvest. On the other hand, knowing how the feed is consumed is also important. If the feed is not enough, shrimps grow more slowly and may try to eat each other. On the other hand, if the feed is too much, it may pollute the water, thus resulting in a poor water condition, leading to unhealthy and even dead shrimps. Therefore, we want to detect the feed residue in real time with our AI technique. Here we show the feed detection under different lighting conditions. On the other hand, in the upper right figure, we detect the amount of feed residue along the time. Therefore, we can measure how fast the feed is consumed. With such information, you can adjust the frequency and quantity of feed dispensing in order to develop a better feeding policy. Here we show an example of smart shrimp feeding. First, one day's feed is divided into 12 small dispensings. Each dispensing is carefully monitored by our AI technique to observe the length of the consumption time. Therefore, we can achieve a feeding plan with multiple smaller meals that result in better water quality and balanced feeding and exercise. So the shrimps grow stronger, faster, and healthier. We also measure the length of shrimp's intestine or shrimp's gut. The left figure shows a shrimp with a full intestine, which means it is healthy and well-fed. The middle figure shows a shrimp with a partially full intestine, which means it is either insufficiently fed or becoming unhealthy. The right figure shows a shrimp with an empty intestine, which means it is unhealthy or in severe lack of feed. This is an example of intestine analysis. Here, seeing the decrease of the average intestine length, a warning can be raised to the manager to check whether the shrimps are sick or the feed is not enough. The underwater camera can be combined with other network devices, such as feeders and aerators, to become an integrated smart farming system. These systems are connected to the cloud server through wired or wireless network. The cloud server provides many AI services, as we explained before. Finally, there is an integrated console for all these capabilities. And this is the cloud-based integrated console. On the left side, there is the image area. In the middle area, there is the sensor and the underwater data areas. On the right side, there is the device control areas. Our system could be even smarter. We will perform AI computing locally on the farm site, send only processed information to the cloud. Thus, makes the system more secure, cost-effective, and reduce network bandwidth and cloud computing and storage requirements. This is a prototype of an edge device, which enhances the image, detect the objects that you are interested in, and send only the relevant information back to the cloud. This is another edge device. It detects feed residue and sends the information back to a smartphone in real time. We have tested our system in many commercial sites, mostly in eastern and southwestern Taiwan. Where are the major shrimp farming areas in Taiwan? Congratulations! As a recognition of our potential, we have won the Future Tech Award 2021. Our technologies will be demonstrated both virtually on the internet and physically in Taipei World Trade Center. Please visit us by checking the following website. Finally, the bright future of smart farming has come. You are welcomed to join us as users, partners, or investors. Let's work together for the rich opportunity lying ahead. Thank you very much.